What is plating? Plating, a surface finishing, deposit a layer of metal or alloy onto a conductive surface by electrolysis. The base material substrate must be conductive, either metal or non-metal, e.g. plastic, treated for conductivity. This enhances appearance, durability, and corrosion resistance, making it vital across industries. How does plating work? Step 1. Pretreatment. Clean the substrate thoroughly to remove impurities for smooth plating. Step 2. Immersion. Submerge the substrate in an electrolyte solution containing metal ions. Precisely control the electrolyte for a stable and consistent electroplating results. Step 3. Electrode connection. Attach the substrate, cathode, negative, and a metal electrode, anode, positive, to a power source. Step 4. Plating. Metal ions in the solution bond to the cathode. These positively charged metal ions gain electrons at the cathode, forming a solid metal layer via reduction. Step 5. Surface finishing. Rinse and polish the plated base material for desired finish. 3 types of plating. Barrel plating. For small parts, e.g. screws, nuts, bolts, tumbled in a rotating barrel for uniform coating. Since one rotating barrel can hold multiple parts, this method is less expensive for electroplating large quantities of parts. Rack plating. Rack plating works best for non-rotatable large-scale parts, which is fixed on racks to ensure even exposure to electrolyte. Reel-to-reel plating. This method is primarily used for processing continuous linear materials such as wires, strips, and plates. The substrate passes sequentially through chemical baths and plating stages to ensure uniform coating deposition across its entire length. Suitable materials for plating. The plating process reinforces metal parts and enhances plastic parts' functionality. It suits different materials. Metals such as steel, copper, brass, aluminum makes them shinier and rust-proof. Plastics such as ABS, PC must be coated first for electricity. Plating metal onto plastic components enhances both visual appeal and durability. Common electroplating coatings. Zinc plating, primarily for corrosion resistance, widely used on steel products. Chrome plating enhances wear and corrosion resistance, often for decorative finishes. Nickel plating provides corrosion resistance and hardness, used for both decorative and functional coatings. Other metals/alloys can also be used, depending on material properties and application requirements. Pros and cons of plating. Pros. 1. Creates a shiny metallic finish, significantly improving appearance. 2. Dramatically increases part durability and resistance to rust/corrosion. 3. Makes non-conductive materials, e.g. plastics, conductive for better electronic performance. Cons. Environmental. May produce hazardous waste, risking operator safety and pollution. Cost can be expensive, especially with precious metals like gold. Coating thickness. Achieving thick, even layers is challenging due to difficulty in balancing internal stress and uniformity. Typical applications of plating. Automotive, chrome-plated bumpers, wheels. Electronics, gold/silver-plated PCBs for conductivity and safeguards components. Aerospace. Critical aircraft parts, e.g. bolts, fasteners, are chrome-plated for extreme durability. Medical. Corrosion-resistant surgical tools/implants for corrosion and wear resistance. For plating services, explore Zintilon's surface treatment solutions. We offer a variety of plating options, as well as professional machining and surface treatment processes to ensure that your parts meet the highest standards. Like/share if this helps for more exciting content.